So I've been enjoying it so far. It was pretty good. The party yesterday was amazing, I think, and Rome is fantastic. So um, distributed configuration with Clojure. But before, in the meanwhile, in chemistry, fluorine is a pale yellow gas at room temperature. It can be liquefied if you cold it hard enough to go like down minus 188 degrees Celsius. It's extremely reactive. That's a very interesting element in the table of elements. Of course, it's very poisonous. And maybe the interesting fact for the talk of today is that it tends to form compounds with almost every element, even the noble gases. And I think it's like an interesting metaphor for configuration in which every application, which is not trivial and needs to run in production, has some sort of configuration. It might be very basic, like a file. It may be a little more interesting, like some system like Zookeeper or etcd. But as far as I know, each application I've been dealing with in my professional life has always had some sort of configuration. So it tends to be everywhere, like fluorine if you don't pay attention. So I'm going to go through just a little bit of definition. At least we know when configuration is a pretty large, is a wide spectrum of things you can do with an application. So we're just going to define it a little bit. What are the key aspects and what are the available solutions? And a model that, in my opinion, is solving at least the problems that I have in my current professional activity. I'm Reborg on Twitter. You might know that handle, and on GitHub as well. Currently work at the main online, quite a big Clojure application out there. And I also publish these weekly posts, although they're not sometimes constantly weekly. I'm lazy sometimes about Clojure and things that are interesting in the Clojure world. So definition. I don't think there is a perfect definition, but in my opinion, configuration of application is any external handle that you can somehow tweak in order to substantially change the behavior of the application. Of course, there are many things that are behaving this way, and so configuration definition is blurring into features of an application sometimes. Examples are like typical examples, the way you want to see your application to change behavior based on environment. So if you're on local development, you want some specific configuration that is connecting locally maybe. If you are on integration, there's a different configuration and so on until production where maybe your hosts, IP, things like that are changing. I think we can consider also configuration, the user configuration, like the settings menu that sometimes you have in applications, both web and desktop applications. You have a settings. If you go in as your user, you can change the configuration application, and something that is peculiar about that is it needs to be stored, so when you come back in, you still have your configuration. And we can go like push this to the extreme into multi-tenant applications, where like you have some settings maybe stored in the database, and when you fire up the application is fetching those settings. It is setting the entire application UI themes, a lot more deeper concepts based on your user, usually a corporate, like think about Slack, and the fact that you have your Slack for your company and another company has their own Slack, and they are completely different. And that is blurring a little bit into the feature. You can call it configuration. Maybe we are talking about a proper feature of an application. More properly, feature toggles. This is something that we're using quite a lot at the Mail Online. Almost every feature is deployed into live with some sort of feature toggle that allows us to decide in which way it should be deployed. So it should go initially to some specific channel, maybe sport, and maybe just for Australia and not for the US. And we can tweak all of these things while the application is running. And this is the definition of feature toggle. You can turn it off and on, or if it's more intelligent, you can do different things. A/B testing maybe is one flavor of that, where you decide between two features instead of a single one, and the way you use this data then is up to you, but usually is to discover interesting patterns and see which one of the features is most interesting for your users. Then we can discuss a little bit of like the different dimensions of configuration. So one maybe is the value lifetime. Things like the host for the database is supposed to stay stable for at least for the application, the running lifetime of the application. So maybe it's a bootstrap thing. So when the application starts up, it reads this from somewhere and it stays like that. But there might be other kind of values with a different line time, like a scheduled time. For example, every week, some report is FTP'd into some location, and your application is restarting, maybe daily, maybe weekly, and picking up this file and do something different. Or real time, and I'm thinking more about feature toggles that I was talking before. And one maybe things that is important is that if you have feature toggles, you usually have a conditions. The way you decide that your application should follow a different path is decided at runtime. So you have an if it's this, then do this. If not, else, do something else. Storage backends, it can be inside the source itself, usually like maybe in Java. Although this is not suggested and is not very common, you can have a class that is dedicated to constants, but as I said, it's not very used. External files are maybe much more common, so you have some file that you're reading. You can have relational databases, so you store them in some sort of tabular form, and you can read them real time. Key value stores is similar in concept, but it tends to be separated from like the business data of the application that you tend to store in a more isolated, consistent, transactional data store like a relational database. Or you can have just dedicated services, and I can mention a couple that I know, Zookeeper, etcd. They both have features dedicated to configuration. So they say in the documentation somehow that you can store config and then you can read config. And they also have a very nice feature that is that you can push value to the application, push changes of the configuration to the application instead of reading them in a pull way. They tend to push to you, or you can have that if you use those specialized products. A little bit, another kind of distinction is about organization. If you have files, you can have single file, multiple files. If you have units, so not necessarily files, they can follow the same convention. You can organize configuration into tables if you use a relational database, or you can go hierarchical, like in the case of Zookeeper, where you have a tree. And a tree is, as far as I can say, one of the best options to in flexibility of organizing the configuration. Or we can talk about caching. So if you have a pull model compared to a push model, if you have a pull model, you might certainly have the problem of deciding what you want to do. If this is a feature toggle, is a live value that you want to read, you can decide to read it every single time. Think about something that is networked, like a database. You might have a performance degradation. It might not be suitable for the application. So usually what happens, you cache this configuration somehow in memory, and then you have, as soon as you do that, you have the problem of, all right, so now it's cached when we are going to expire it. When the application is supposed to know that there was a change in the configuration and pick that up, and you can use TTLs for that. You can check timestamps and doing it in a more custom way. Worth noticing that if you have the push model instead, this is not related. It doesn't force you to have any kind of cache, and the configuration is just pushed straight to you. You can, like, as the application, decide to do nothing about it. Usually, in our application, what we do is we bounce a few components. So with that, I mean they become aware of the new configuration and they behave differently. And then distribution is another important aspect. And this is especially for clustered applications. So if it's like our environment, you might have an environment where your application is running on multiple instances. Each one of them can receive one of the requests. And in that case, if the configuration changes, you want this configuration to be propagated to all of them. Hopefully, in a almost synchronous way. You don't want like a partition of the cluster to know about the old configuration and the other partition to know about the new, and work in this like in two different worlds. And this might also involve the fact that you need to coordinate a local cache invalidation. It's the same as the single instance application, just if you have a cluster, you have to coordinate that case as well. Last aspect is that I want to talk about is versioning, and that was probably the key aspect that made me think about a different solution for this problem. And because what at least was very important for us is that we have a lot of feature toggles. So the configuration, if you look at the configuration, it might seem very complicated. It's quite long. There are many features. Some of them are old, some of them are new. We tend to clean up them every once in a while, but there are quite a substantial number of them. And you want to know, when you're pushing a new configuration to the live environment, you want to know what you're pushing. You want to see a diff, for example, of what values are about to change. And you want to be, of course, also, you want to be able to revert the configuration if anything goes wrong into the running cluster. So this is especially true for feature toggles that are like impacting on the live environment. And if you push this kind of configuration, you want to be fast in recovering from an error in the configuration, and you also want to be able to diff them. So versioning is, in my opinion, a key aspect for configuration. So going in slightly more deeper details, I'm just picking one possible products of the many, like for relational databases or key value stores or specific products. And I just want to highlight that for each one of them, there is no a single column that is all green. There's some of the aspect that is impacting on your development life cycle in terms of you might need some effort to put together a custom solution. There might be some inflexibility or a lack of flexibility in doing some other kind of stuff. Just wondering if going through maybe one of them, one or two of them. So let's pick the first line, for example, updating. So if I'm using plain text for configuration in that case, the updating actions, so the way the application is going to read them, if I push or pull, it's something that I need to do custom. That can be a library, of course, so there are many solutions already for that kind of problem. Use your library, but still, it's a custom action you need to do. So maybe it's not that much of effort, but it is something that you need to do. For MySQL or for other databases, usually the way you can be pushed about changes is by using triggers. Triggers have the drawback that they sit outside the application. So you have this part, sometimes very important part of the application that is sitting in the trigger. And this trigger is sitting in the database. And then it's not part of the same place where you see all the rest of your sources. So that might be a problem. Also, programming trigger is not always done, if it's done in pure SQL, is not maybe the best language to do these kind of things, or there are better options. Redis, for example, if we talk about updating, they have a way to push you notifications. You have a client, and you use the Redis client, it will push the notification to you. Fantastic. etcd is the same thing, it's got watchers. I'll take another one, and then we can move on. If we go down, for example, to the diffing or the versioning, which are kind of connected, and you go plain text, you have this nice thing that almost every versioning system has a way for you to do diffing of files. So that comes almost for free. You have a tool that is already doing that, is making things colorful. You see exactly what is changing. And at the same time, it's a versioning tool, so you can revert quite easily. So from that point of view, it's a very good solution. But if you go into, for example, MySQL, Redis, or etcd, they are not using like a pure text approach. Of course, they are storing something that is pure text, but in order for you to do this diffing or versioning, you need to have some way of synchronizing something that is on the file system into something that is inside this kind of database, which is stored in usually in a binary and proprietary format. So it's doable, and there are also tools for doing that. I'm just saying that is a custom thing, and you need to think about it. So can we do a better, and for better I mean, can we have all of the greens in a single column? And this is what I was trying to achieve with the idea that I'm going to illustrate to you now. So plain text, possibly a hierarchical model, which is a push model, so I can receive configuration changes as much as I want. I don't need to pull. I don't need. I can even cache them, but they will be expired as soon as the new configuration is landing on the app, which is possibly distributed because we have multiple nodes, and also possibly it's dedicated to configuration only, because another thing that is bloating into both Zookeeper and etcd is that they also offer you other things that you might not want or don't necessarily need. This distributed locking thing in Zookeeper is quite big. So it's impacting in the documentation, in the API you need to use, and in the way you need to maintain the cluster, the Zookeeper cluster. So it's impacting on you, the fact that you have distributed locking and you're not using it. If you're using it, good, but we're not. So the model is that I'm proposing is a client-server model. I think the most important part of this is that it's a layer that is growing on top of a file system-based configuration. So we have already configuration files containing all the configuration that we have, and we want them to sit in Git or another versioning system, so we can use the diffing tools. And we want, or it would be ideal to have something that is sitting on top of this, is figuring out if and when there are changes, and is propagating them to all the listening clients. So it's a little bit like Zookeeper or etcd is doing, or a database is doing. The only difference maybe is that it's using a push model. So whenever there is a configuration change, each and every node in the cluster is getting the configuration change. And maybe some important aspect of this is that every node is connected to like multiple of these servers, all serving changes to the configuration. And it's important, this is an important fact for failover of the configuration. So what I certainly don't want is for any of the running application to be dependent on the configuration server to be up and running in order to continue running. So what can happen anytime is all the servers go down, fine, but the application needs to continue running, of course, with whatever version of the configuration is loaded at that time. That is the important thing. There should be no network connection that is breaking and stopping the application from running consistently. So why functional? I've used Clojure to write this server-client application, and I think functional is a perfect fit for the kind of, especially for the kind of concurrency model I'm looking at. So when I think that each client is receiving multiple updates, maybe sometimes multiple updates of the same configuration, I really don't care. I'm not interested in the fact that, for example, it is receiving the new configuration from 2 of the servers, and the other 2 servers for some reason are not sending it. The important thing is that there is something pushing, and this pushing to the client that is receiving the configuration can be concurrent as much as I want. And this is a perfect fit for an immutable, a functional language that supports immutable data structures, because I can push as many of these changes, and there won't be any chance for one of these clients to see half of the new configuration in the fly and half of the old configuration because the update is still running. Because thanks to immutable data structure, the kind of concurrency model is a compare and swap semantic, the casting there. And this is perfect for this case. I don't need to be completely transactional. I just need for one change to be atomic and to read it as an atomic change. Another aspect maybe that is important is that functional languages, especially the Lisp family of them, is coming with this concept of liveness of the system. They are not the only one. There are also object-oriented systems with this liveness of the system, of course. But especially in Lisp languages, it's coming. It's assumed to be there. It's almost a granted fact. And for this reason, it's working very well. And why it's important? Because my system is a live system, and when it's receive a new configuration, it needs to be able to potentially swap a function with another behavior completely and work in a different way. And especially for Clojure, what I liked about this solution is I was able to use atoms as the model of concurrency, which is supporting exactly the behavior I want. Multiple changes all arriving at the same time, and they're not impacting on the client reading a new configuration in isolation atomically. Metadata, I'm using them to store data about the raw format of the configuration file, so multiple clients written in other languages can read it. So I wrote it in Clojure, but with the idea that it should be able to serve any application that can talk WebSockets, basically. For that reason, there are wonderful libraries in the Clojure landscape, like Aleph and Manifold, that I'm using for exactly for this reason. They support this networking, and I don't need to think about it. I just need to use them, and they're very easy to use. And Java interoperability is giving me access to Java NIO primitives to listen to file changes. So I don't need to think about which operating system I'm deploying it onto. The JVM is doing that translation. If I'm on Linux, is using the Linux way to propagate file system events. If I'm on Windows, is using the Windows way, and so on. And since it is not written yet, but I'm planning to write it almost right away, I was thinking to write the JavaScript client for this, to have a client written in JavaScript to be able to receive this configuration. Is probably coming for free, almost for free, by just generating Clojure script from the current Clojure client. This is at least my hope. So I want to show you a little bit how it works. We are going to see a little demo running. We are going to fire up 4 servers that are sitting on top of a very simple branch in my file system that is containing a few folders, subfolders, and some file. And we are going to fire up 1 client, 2 clients, maybe a little more, to listen to these servers, and then we'll try to change the configuration and see what happens. So you're going to see a little bit of logs moving around. So let me just, and this will be the bit where I need to drag and drop this. So I'll make it bigger. How does it look like? Can you read? It's okay? All right. From I cannot see it. Yeah, I have it under here. Let me see if I can do it. Okay, so let's start the servers. Then we can follow a little bit of the server starting up. We can see a couple of interesting things. Let's give it 1 or 2 seconds. When each server starts up, it's just printing a few things about what is the root folder is looking at, or which port it's listening to, and things like that. And some warning. Yeah, don't be worried about that. There's not enough entropy, but we shouldn't be worried about that. Okay, let me start the client. So if I go here, you should see, better if I leave it in the middle, I suppose. We see the client starting up, and when the client starts up, the first thing it happens, it connects to the server, and the server, the first thing the server does is to push a new configuration to the client. And you should, let me check, before it starts to ping, you see this line here? Okay, let me highlight it. Okay, this is the configuration. This is the result of, oh, I forgot to show you, by the way. At the top here, as soon as I can see where the cursor is. Okay, at the top here I have like a few applications, subfolder, one subfolder for each application. And I decided that my client should listen to the top one, I think. No, this one, this test JSON thing. And inside this test JSON thing, there are a few files, like this SAM JSON. If you go inside, you can see that it's just like a sample JSON file. And this is what you can read then if you go back to the line here. So the client number 1 says, I received the configuration, I can read it, and it's ready to run basically. So let's fire up another client just to make a little bit more noise. I need to kill the logs for that, just to see the, and the client is coming up. Maybe an interesting thing to notice is that each client coming up is receiving a push from the configuration, for the configuration by each one of the servers that are running. So that was one aspect that when I thought about it, I said, oh, that might be a problem because why should I receive the same message all over again? And then I thought about it, it's just fine, because in terms of scalability is going to impact only if you have millions of these, I suppose, or if you have megabytes of configuration. At that point, you might have other kind of problems as well. So I just decided to leave it as is and let the concurrency and immutable data structures to deal with the problem of receiving multiple of these messages all at the same time. I don't really care. So let's try to make a change. And now it's going to be difficult. Okay. Let me sort of. Help me. So let's carry on some vector things. Is it correct, Jason? Yeah? All right. Save it. Let's see what happens. Now, the machinery is about to send stuff. So you can see many messages coming as a nil thing. It's because it's the same client receiving the configuration multiple times, but at the top of that, it is actually receiving the change configuration. And you can see it here with the carry on now coming through. And the same client is then receiving the same messages, so it is printing the diff. So the next message is printing nil because there's no diff. But the first one is the one that we're interested in. And it goes on like this. So let me go back to the slides. A couple of technicalities about this. Problems that you might need to solve. Um, keep tracking of connecting clients. So that might be interesting because I need to clean up from the server perspective, since at least this initial implementation is using WebSockets. I don't have any other way to know if a client went down for a proper reason or is just a temporary disconnection. So if I see a client that is reconnecting again, I'm assuming it died for some reason, and I have the previous WebSocket state that is still in the server state, so I need to clean it up. So I need to keep track of all the connecting client. If the same client is connecting twice, well, I'll clean up the previous state and say, oh, hello again, send the configuration, the current configuration again. The keep alive pings are for firewalls. Some of them, they usually are friendly with WebSocket connections, but if nothing is passing through the pipe, they might decide to drop the connection. So I'm pinging, and you probably noticed the messages of the pings going through. They have local caches. As I said, when you have a push model, you don't have the problem of the cache invalidation in the sense that you invalidate the cache every time there is a new message coming, throwing away the previous configuration and taking the new. I'm supporting both JSON and Eden. Eden is the format, the standard format for Clojure. It's got a specification, so you can use it from JavaScript as well or other languages. But it's definitely the most used in Clojure land. JavaScript client, as I said, is in the process of being written. And all the code is in that repo on my name. It's called Florin. And that's all, I think. I think this solution is serving us well at the moment. It's not deployed on the entirety of the application. It's running on part of it. Yeah, I think that's all. So if you have any questions.
In short words, what exactly makes, what's the best, the biggest advantage of this distribution of configuration over well-known distribution configuration management, not distribution systems, because they are slightly different, I know Chef or Puppet. What's the biggest advantage?
So I think when you use Chef or Puppet, you get the distribution mechanism based on those. So you can push files on a distributed system. Then the way the application is picking up that file is the custom part. You have the option of sending a no-hop to the app if you don't want to kill it. That's usually the best way. You don't want to kill the application if you can. So you maybe send a no-hop, and you need to create the code to react to the no-hop and reload the files. So yeah, it's not a completely difficult solution, and I suppose many systems work that way. But you have that kind of moving part, and by using this, you get it in the client. You don't need to code it yourself, and also caching is handled by the client as well. So that would be, in my opinion, the advantage.
Hi. One thing that I didn't understand was the transmission of the differential that you derive. And so I'm wondering if there's a scenario where because a connection might drop and get reestablished or something, or any anomaly with TCP, that you might deliver those differentials out of order. And is there a case where when merging those differentials out of order that you risk an inconsistency across the nodes?
So maybe the thing is that there's no such a thing like sending two different versions. Well, okay. There might be if you are updating the configuration in a very fast way.
Yeah, that's precisely the scenario I'm thinking of, or a concurrent addition, right? So it doesn't even have to be fast. It could be that two people make a change roughly around the same time, and so you have two in quick succession that may arrive out of order.
Yeah, that's is something that you need to solve at the like process level of why two people are doing the change at the same time. There should be, at least in our case, this deploy of the configuration is connected to a Jenkins job. So when you click run on the Jenkins jobs, and you might have different way of synchronizing, but uh, the Jenkins job is in a running state. There's no way to click it twice. Or you can click it twice, but there will be one configuration change and then another. And that is the case that happened when, based on Zookeeper, we had the configuration. And the problem with being based on Zookeeper is that in that case, we were not really able to understand what was the change that went up and how to revert it based on what was the change. Then we invented a way to post the configuration on Slack to check and verify it, but we didn't have the diff. And so you had to copy paste the configuration from Slack into a diff thing, figure out what was changed and revert it. So for like multiple people in the organization always wanting to change the configuration at the same time, this is not preventing you to do that. It's a process part that you need to figure out. Who is doing the configuration when QA needs to be involved? Maybe not, maybe yes.
Right, and so I guess just to riff on that same scenario with the out-of-order messages, it seems like another possible scenario is drop messages. And so something like Zookeeper, one of the benefits that you get from Zookeeper and Zookeeper's atomic broadcast is that you get the guarantee that you'll have delivery to nodes that are considered part of the current view. And so I'm wondering, yeah, it seems like in the ideal operating case, or in ideal operation where there are a few network partitions, something like this is fine. But in a scenario where you're trying to reconfigure something because there's a network anomaly and you need to get a majority of your nodes online and reconfigure them to like kind of stabilize the environment, it might be difficult to perform that stabilization if you're dealing with these drop messages without consensus.
The way you deal with it is you increase the number of servers, you put them in geographically distributed areas, so you have that kind of like failure, way to deal with failure, and then one of them will be able to send the configuration. This is what should happen. If none of them is able, of course, you don't get the change, but then you have another kind of problem if 5 servers are going down.
Okay. What about the difference between your solution and the other configuration-specific ones like the Netflix archives or Spring Cloud config?
I don't know about them. I tried to solve the problem that we had with the current products, and I had to look around for what are the other products in this scenarios. But when I did the search, I could only find etcd, Zookeeper, and file-based solutions based on libraries, but they were not solving all the problems. So I'll be happy to take note of, are there solutions for this, and see if this can be improved based on those, or I did a completely useless work. But this is it was like very simple application too, at the end.
It seems to me that there are two scenarios here. One is where you change the configuration, you leave the code intact. So what needs to happen is what you showed. The other scenario is where you deploy a release, and very often you have to tweak the configuration at the same time. So you don't want any binaries to come up with an old configuration. You want some synchronization there. How do you deal with that?
Well, every time the client at the moment is configured, so every time it fires up, it is connecting and receiving the newest. So in case of a redeployment or a redeploy, at this point is if you kill the app and you restart it, it's going to get the latest. Is that answering the question?
Does that mean your configuration doesn't have to be forward compatible, like backwards compatible? You can never like delete configuration options.
No, because the previous one is just disappearing as soon as the client dies. It's just in memory. There's no like other kind of caching. So the client starts up again and it just gets whatever is the latest. If anything was deleted, it's just going to be wiped out and start again. So there's no like this kind of logic merging stuff because there's no local state apart from the memory.
Thank you.
Let's thank the speaker again.
Thank you. If you don't pay attention. So I'm going to go through just a little bit of definition. At least we know when configuration is a pretty large, is a wide spectrum of things you can do with an application. So we're just going to define it a little bit. What are the key aspects and what are the available solutions? And a model that, in my opinion, is solving at least the problems that I have in my current professional activity. I'm Reborg on Twitter. You might know that handle, and on GitHub as well. Currently work at the main online, quite a big Clojure application. Typical examples, the way you want to see your application to change behavior based on environment. So if you're on local development, you want some specific configuration that is connecting locally maybe. If you are on integration, there's a different configuration and so on until production where maybe your hosts, IP, things like that are changing. I think we can consider also configuration, the user configuration, like the settings menu that sometimes you have in applications, both web and desktop applications. You have a settings. If you go in as your user, you can change the configuration application, and something that is peculiar about that is it needs to be stored, so when you come back in, you still have your configuration. Today is that it tends to form compounds with almost every element, even the noble gases. And I think it's like an interesting metaphor for configuration in which every application, which is not trivial and needs to run in production, has some sort of configuration. It might be very basic, like a file. It may be a little more interesting, like some system like Zookeeper or etcd. But as far as I know, each application I've been dealing with in my professional life has always had some sort of configuration. So it tends to be everywhere, like Floration out there. And I also publish these weekly posts, although they're not sometimes constantly weekly. I'm lazy sometimes about Clojure and things that are interesting in the Clojure world. So definition. I don't think there is a perfect definition, but in my opinion, configuration of application is any external handle that you can somehow tweak in order to substantially change the behavior of the application. Of course, there are many things that are behaving this way, and so configuration definition is blurring into features of an application sometimes. Examples are like so I've been enjoying it so far. It was pretty good. The party yesterday was amazing, I think, and Rome is fantastic. So distributed configuration with Clojure. But before, in the meanwhile, in chemistry, fluorine is a pale yellow gas at room temperature. It can be liquefied if you cold it hard enough to go like down minus 188 degrees Celsius. It's extremely reactive. That's a very interesting element in the table of elements. Of course, it's very poisonous. And maybe the interesting fact for the talk